Possibly what you've seen in grade 11, just continue along with the law of conservation of momentum. So how conservation of momentum works is that the momentum before, if you add up all the momentum in a closed system in an event, and then after the collision or after some event occurs, the momentum before must equal the momentum afterwards. So here's our question we'll look at right now. So we have a 10,000 kilogram railway car traveling at a speed of 24 meters per second strikes an identical car at rest. If the cars lock together as a result of the collision, what is their common speed afterwards? Okay, so how we always start these ones, it's always momentum before is equal to the momentum later on. We don't actually have to write this line at the top. I'm just doing it just to hopefully clarify the problem. So we have, let's think about what's happening initially. So we have a 10,000 kilogram railway car, and it's going to hit an identical car at rest. So I'm going to draw those out. So I have a car and a second car, and this one is moving to the right. So this is it's called object 1. This is object 2, and the mass of object 1 is 10,000 kilograms. The mass of object 2 is also 10,000 kilograms. The velocity of object 1 is 24.0 meters per second, and the velocity of object 2 is at rest, so 0 meters per second. So we have to translate this scenario into an equation. So we know that the momentum forward is just the addition of the momentum. So in this case, we have m1v1 plus m2v2. So they have some total combined momentum. I'm going to put an equal sign right down along this middle line. Oh. Sorry, don't need it right there. It's not my equation yet. Okay, so this is my beginning of equation. I have an equal sign right there. Let's see what happens afterwards. Afterwards, it says they collide and they stick together. So they stick together and they now have a total combined mass of 20,000 kilograms. The velocity is unknown. So I just get to my m1v1 plus m2v2 is equal to m3v3. There's only one object after the collision. Now if I plug in all my values, in this case all the masses are identical for the left side, so I can say m times 24.0 meters per second, and that's plus m 0 meters per second, and that's equal to, well, there's two m's, so they're all combined, and that's some unknown. So we can see that we get 24 meters per second is equal to 2v3, because the m's canceled out, and that was 0. So we end up with v3 is equal to 12 meters per second.